Good afternoon, everyone. So, yeah, APs gets a lot of focus, right, when we talk about Wi-Fi. But today we are going to talk about the other endpoint on the link, which is very important, as equally important as the AP. So we are going to talk about station testing, and of course, we'll be talking about few insights from our testing as well. So before I go into the next slide, I'd like to ask you, how many of you have Wi-Fi devices in your home from 1 to 10 Wi-Fi devices? Can you please put up your hands? Okay, almost all of you. How many, do you guys have more than 10 devices in your home? I see a few. Shivam raised his hand. So probably this is how Shivam house looks like. So today's house, right, smart homes are expanding. So you see more and more devices are coming online. So internet connectivity was like never before. You see smart refrigerators. You even have smart washing machines and voice controller systems which controls other devices. You even have thermostats, you even have surveillance cameras. So clients are diversifying basically, and the scale is also increasing. Not just diversification, but what a station device can do in terms of its capabilities are also changing drastically when compared to the past. So if you take a smart refrigerators, for instance, in the past, you might have bought it just because it says, I have Wi-Fi. But what did you do with it? Probably nothing, because there is nothing much to do with Wi-Fi on a refrigerator. But what's the case today? They are getting very smart. You can see what's inside the refrigerator with the camera that's placed inside, and fridge would give you the smart recommendations based on the items that are in the fridge. It recommends you recipes, and if you are a very hardcore tech guy, you even have Spotify or YouTube Shorts right on your refrigerator screen. So capabilities of station device are also expanding. So let's talk about few numbers. How big is the scale? You have around 20 billion plus Wi-Fi devices active all over the world today. Think about the number, it's very huge. And who are contributing more? Of course, the station devices, right? And if you take the monthly consumption of users in the US households, it's around 650 to 700 GB. And as few of you have raised your hands, most of the US households also have around 17 devices, right, in their homes connecting to the internet. So as I said, the scale is increasing, and what's the projections for the future? They are likely to increase. And who are contributing here? Probably IoT devices. So you see more and more devices getting online. So smart bulbs, security cameras, everything is getting online. So connectivity today, the world is connected today like never before. So connectivity is at its peak, I can say. Now let's look at this perspective of testing station in an access point versus testing Wi-Fi in a station device. So a few of the interfaces on an access point that you would usually find, of course, the Ethernet for the backbone network. You have the Wi-Fi interface to client your wireless devices. You might have USB, Zigbee, Bluetooth that are coming probably in the latest Wi-Fi AP models. So primary intention is to provide Wi-Fi. So Wi-Fi gets thoroughly tested on access point because that is what it intends to do. It's a layer 2 device. But on the other hand, you have station device like mobile phone. It's complex, I can say, when compared to the AP, because what you can do with this device is a lot more diverse, right? You run multiple applications on it, and those applications would interact with lots of hardware modules, like the camera module, for instance. And if you're watching a video, it has speaker systems involved. And of course, you are watching a video means there is a display module involved. And of course, there is Wi-Fi module and cellular modules for internet access. So the hardware components are diverse on the station device. So if I am a station device vendor, I would want every of my hardware component to be well tested. So in that process, very thorough and extensive testing on Wi-Fi module might not be performed on use case basis, right? So that's the thing. And what are the different stages of station testing from Wi-Fi perspective? Initially, we need to start from the radio itself, right? We need to check the radio module if it is complying with the regulatory protocols. So probably FCC rules or ETSI rules, things like that. And we need to check for basic connectivity, whether the module is getting connected to the access point or not. And then we move to the integration phase, where you take the actual module and place it on the system and see how it is interacting with the OS. And here comes things like how it is coexisting with other radios, other radio interfaces on the system. And then the deployment phase, where the device is actually handed to the user. So here he can do whatever he wants, right? He can move around. There could be other multiple devices in his living home. So testing with other devices and interference, things like that are a priority here. You may ask why testing a station is important, right? Because let's talk about some of the use cases. So if you are wearing a VR headset and if you are streaming a high quality 4K 360-degree spatial video and you are roaming, so you don't want audio lag or video getting frame drops, right? So roaming is a key aspect for the Oculus device. And if you are taking surveillance cameras, these devices are gaining popularity these days because you'd want security, right? And you don't want to miss any motion captures that are happening around your home. So these devices need connectivity. So connectivity is a very critical aspect here. And if you take about healthcare, which is a very critical domain, because there is a life, it is tied to humans' life, right? So it is not just about connectivity, it is about the data transfer continuously without any errors. So these kind of things are uptime and reliability aspects are very important with the healthcare systems. Now, what about latency and packet loss? These devices need to process your voice real time, and they need to give you feedback in real time. So packet loss could be a major factor for devices like HomePods or Alexas. Big picture. So these are all the stations. As I said, stations are getting diversified. So how do we test them, right? So let's put them in some verticals. So these are the different verticals that we have put. So you have surveillance cameras, you have medical equipment, and then consumer devices where you would actually use them. So roaming kind of things are important here because you would actually carry the devices with you. And then we have retail and industrial vertical. So if you guys heard about Boston Dynamics, they are using a Spot robot that also has a Wi-Fi module in it. So verticals are increasing, stations are diversified. So what did we have from our test results? It will be discussed by my colleague Deepika.
Let me begin with one of the demanding Wi-Fi station in recent times, VR headset. Anyone here used a VR headset? Okay, so with devices like VR headset, the key whereabouts would be, of course, the Wi-Fi connectivity. We expect it to connect to our access point. And then we, for example, if we are very kid and if we are doing some video streaming or if we are playing some games in the VR headset, we expect it to perform consistently well in all the antenna orientations, right? Because we'll be moving our heads, we'll be moving from one place to the another place, from one room to the another room, if we are using a mesh home network in our house. So we expect it to successfully roam between one node to the another node as well, right? So roaming is one more important aspect in this VR headset. And if we are streaming the video for like longer durations, if I want to play games for like 5 to 6 hours, and again, stability is an important aspect. So when we tested this VR headset across all these different dimensions, what we observed was this VR headset has actually performed well in majority of this test cases. But there is one specific test case where we'll be testing the VR headset in a real home scenario. So we won't have a VR headset alone in our home, right? We'll be having all our laptops, our mobile phones, and IoT devices doing the respective traffic, downlink, uplink traffic, right? So when we tested this VR headset in such a situation, what we observed was this is actually a real-time throughput graph with the VR headset. So first, we're just starting the traffic with just the VR headset. And when this home in a box kind of traffic was started, what we observed was the throughput is dropping all the way to 0. And when this home in a box traffic was stopped, and then it again going back to its normal state. And then we repeated this test for one more iteration. Again, it's dropping to 0. So at this point of time, when we initiated ping from the 80s upstream to this VR headset, what we observed was the ping response times were also noted to be higher. They went all the way up to like 40 seconds during this home in a box traffic. And then imagine how the user experience would be in such situations. So here is an example video. So this is where when the VR headset traffic was just running, so when we are doing just the video streaming, and when the home in a box, when the realistic home traffic was running at the same time, the video streaming stopped, it halted with a node trying to reconnect. So interestingly, when we performed the same kind of testing with another vendor AP in the same test environment, we didn't observe this issue, interoperability coming into the picture. So let us discuss a few more interesting results with one more common Wi-Fi station in our homes, Wi-Fi smart cameras. So again, Wi-Fi smart cameras. Again, the key care abouts would be, of course, the Wi-Fi connectivity. Like suppose if we are trying to install a Wi-Fi camera in our home, we'll be mostly placing it outside our home, right? So of course, the range comes into picture. The performance, how well it is behaving with respect to the range, with respect to the channel utilization, with respect to packet drops, broadband speeds. And again, when we tested all these different test cases with the Wi-Fi smart cameras, what we observed was the camera passed the basic checks. So the connection time was just within 300 milliseconds. But there are few other test cases. For example, we considered the live streaming test. So when we are doing live streaming with two vendor cameras, there is vendor A camera and there is vendor B camera. What we observed was the throughputs with vendor A camera are significantly lower when compared with vendor B camera. And when we analyzed some Wireshark, when we did some Wireshark analysis, what we observed was with vendor A, the data rate variation was very frequent when compared to the vendor B. So if we can consider the first graph, the throughput, that is actually the data rate, it is dropping all the way from 72.2 Mbps to 7.2 Mbps very frequently with vendor A camera. While the same data rate variation with vendor B, it's dropping from 72.2 Mbps to 65 Mbps, but not all the way to MC0 7.2 Mbps. And again, we also compared WLAN retries with vendor A camera and vendor B camera. Again, the WLAN retries are observed to be quite higher with vendor A camera than with vendor B camera. Coming to the next test case, we also have this performance with respect to the interference test case. Again, we won't be having the Wi-Fi camera alone in our home, right? We'll be having all these laptops, mobile phones doing their respective jobs. So what we have done is we tried to introduce some interference. We increased this channel utilization. We tested this video streaming across different channel utilization levels. What we observed was up to 50% of channel utilization, both vendor A camera and vendor B camera performed well. There was no buffering observed. There was no frame drops observed. But when the channel utilization is reached to the 75%, like if we consider the first video with vendor A camera, we are seeing multiple frame pauses, right? And while the same with vendor B, we are not observing any frame drops. The playback was all smooth with vendor B. And when the channel utilization reached to 90%, what we observed was the streaming actually halted with vendor A camera, while the streaming still continued with vendor B camera, even at 90% channel utilization levels. So these are the reference video examples for this test case. We have one more test case. So while testing all these different dimensions, when we are testing all these test cases, what we observed was, so vendor A camera is not actually supporting 802.11e, it's not supporting QoS, while vendor B camera is actually supporting QoS, WMM. So what we have done was, we had 4 to 5 stations doing high priority traffic like voice and video. At that point of time, the streaming with vendor A, if we consider the first video, when the high priority traffic was started, the throughput with vendor A camera, it completely dropped to 0 Mbps. If we consider the first video, it is actually real-time throughput with vendor A camera. So when the high priority traffic voice and video was active, like at approximately 250 seconds of timestamp, we can see the throughput dropping to 0 Mbps. While with vendor B, the streaming still continued, even at when we have voice and video traffic running. So now Badhiri will be continuing the next set of results.
Thank you, Deepika. So far, we have seen some interesting results with the VR headset and as well as the wireless camera. Now we're gonna see one more wireless device that is common across our homes and residential offices. So that is a wireless printer. So what are the major expectations from a wireless printer? We simply expect the wireless printer to be able to connect to the Wi-Fi network and to be able to do its job, to be able to print the documents which we are sending wirelessly. Yeah, so as you can see here, we mainly tested wireless printer in these two scenarios. First comes with the connectivity part. So what we did was we took a wireless printer and we tested with two different vendor APIs across all the three securities. So what we basically observed was with specific vendor AP, we are seeing relatively high connectivity times. That is like 40 seconds is relatively high when it was tested with this one vendor AP. But when the same testing was done with a different vendor AP, what we see was the connectivity time was kind of good. And then coming to the performance part, so generally for a wireless printer, we expect it to stay at a desk and then with some distance from the router point of view. So the same testing we did with three different vendor IPs across two distance profiles, near and far. So what we observed here was, so with as the far distance profile with AP number 2, we observed like it took nearly like 25 seconds of time to be able to print that particular document. And then it was tested with respect to the congestion part. So we introduced like real scenarios. So in general scenarios, there is ideally no a router and a printer exists. There will be multiple more devices to be able to communicating with the router as well. So in such scenarios, we tested with across multiple vendor APs, and what we observed was with specific vendor AP, we are seeing relatively like 43 seconds of the print time. So which is like more than more time. Then in this time, the user might feel frustrated and then may hit on the print button continuously, and this might lead to even inconvenience. So what we can conclude from these three slides. So as we mentioned from the Deepika's part as well, when the home in the box scenario, which was tested with the VR headset with particular device AP, it is getting the, we are observing an issue. But when the same test case with the same RF environment was tested with a different vendor AP, we are not able to see that issue. So this comes to a conclusion was for the Wi-Fi station vendor, it's equally important for their device to be get well tested across all the top selling routers available in the market. So for example, here what we see was we took the PlayStation as a reference DUT and we have the top selling routers across the market, and then we basically scale them across on three factors of connectivity, performance, and stability. And then we get this PlayStation device tested with all these top selling routers across the market, and then we made the scale based upon this rating. So this highlights the facts that this router test, this Wi-Fi station testing is equally important to be get tested with different vendor APIs. And then coming to the part, so far we have seen what are the test cases we did so far, like the connectivity, throughput, interference, these testings. So how these testing were done. And coming to this standalone setup, to give you a simple example, for example, there is a single station device, single Wi-Fi station device, and single Wi-Fi router device. So what are the test cases can be done, like a performance, connection time, and the stability, these kind of test cases. So these kind of test cases, we can done this using our standalone test bed device, where we can have the LAN ports and the DUT and as well as the Wi-Fi station device. So with the, along with this, if we want to add the distance, so if I want to move far away from the Wi-Fi router device and be able to test the same things, how well my Wi-Fi station device is performing when it is moving far. So we have this RVR testbed where we can do this similar testing with varying distance, and we can see how the parameters are getting varied. And what if this comes with a device like an Oculus or a VR headset, where the roaming is equally important when we want to see how well the roaming is happening between the AP1 to AP2, handoff is getting happen. So here comes the picture, the roaming testbed. There we can see how well the roaming is getting happen, how well your Wi-Fi station device is getting roam. And coming to this, if you want to add even more realism to your testing, like you want to add even more real devices to it, or you want to add like how, like from the previous generation device to the latest generation device, and you want to add it across different various profiles like near, far, and medium. So you can use this home in the box testbed scenario where we can add the more realism to your testing and see how your Wi-Fi station device is actually performing. And coming to the summary part, so as we see, considering a home scenario, these Wi-Fi is more and more Wi-Fi devices are getting online, and more devices are coming into the Wi-Fi category. So these Wi-Fi devices are of diverse and different, they are diverse, differs in shape. So what needs to be taken into consideration? It's not always about the lab numbers which need to be stressed. So it's always about the user experience which matters the most. So nowadays, so it's equally important such that the Wi-Fi station device should be equally tested compared to the router device. So and what needs to be done for it? So there needs to be a specific tailored test case for a specific Wi-Fi devices, and as for there should be a common test plan for few Wi-Fi devices, and as well as few test plans should be tailored specifically for the few Wi-Fi station devices. Thank you.
Thank you, Badhiri. Can we have questions? Okay. Chetan.
I just wanted to know that in terms of association times, reassociation times, did you see a difference between the stations' behavior in terms of, was there a few stations took more association time or
In center.
Yes. So we have seen association and the connection times, overall connection times to be different with respect to the stations. We had seen the results, right, with security camera, with VR headset, and with the printer. So if we consider the security camera, it's just connecting within 300 milliseconds with across multiple iterations. But if we consider the printer results, they're like taking more than 1 second. In some cases, it took more than like 10 seconds, and in some cases, it went up to like 40 seconds.
okay. What I meant is maybe same category of clients. When a client is roaming between APs, the packet losses or the drop in the voice call or the video call, did you observe stations behaving differently in terms of roaming categories also?
So to answer to that question, so we also have done, of course, the roaming is not like purely for camera devices. They're mostly like stationary. But we tested roaming with cameras as well. When we tested roaming with one vendor camera and with another vendor camera, one vendor camera, we are seeing somewhat smooth playback while it's roaming from one AP to the another AP. While with the another vendor camera, the camera did not, while with another vendor, it did not roam actually, and the streaming halted if we consider the camera case.
Thanks. Okay. Srikanth have a question. Yeah.
Question is about the fact that we have a variety of stations now, and especially with IoT as you're motivated. Do you see, and of course, we also have a lot of retail APs out in the market, which is typically facing these IoT clients. Where do we see the problems mostly? Is it on the station side? Is it on the AP side? Can we conclusively say, based on whatever experience, that it's majority station side? Any thoughts on that?
Yeah. So on a whole, I might not comment on whose side the more problem lies, but I do see different behaviors when there are IoT clients involved. For instance, the printer we have talked about, one printer performs better. Yeah. So even though it got a probe response from the AP, it does not move to the next stage. It does not send the authentication request, but it keeps sending the probe request, kind of a thing. But on a whole, I cannot generalize at this point.
Because you had a table where you actually ranked the APs with the various colors and numbers. I'm just curious, what is the genesis behind that? Are you telling the APs that you did good, bad, and not so good? Or, in some cases, you can't do much if the stations do bad. How is your way of our station guys coming to you and saying, hey, help us find these problems? Or it's just the AP sides which are coming and telling you, how do we perform in these instances?
So if I can comment on that, Shrikant. So one of the challenges we're facing is most of the station vendors, what they want to do is, let's say you're making a gaming headset, or one of the biggest challenges is I want to pick the top 20 most popular Wi-Fi routers in the US market, and I want to make sure I work well with them. And if I'm not working well with them, I need to know at least what the problems are, because when I get a support call from a customer, I'm already informed. I can inform this data to my support team. And sometimes, let's say you are a big gamer, so one of the companies is a big gamer, so they actually go to a website, let's say Xbox or PlayStation, they can put a list of recommended APs on their website. because the gamers actually buy the AP for gaming. So they go to the client first before they go to the AP, right? So they can create a list of recommended APs based on these test results. And they can actually give this data to the support team for support issues. That's the reason why we are trying to do this kind of testing. So.
Okay, we will have one last question. Okay.
Mentioned that you have tested QoS also from station side. So you would only check the downlink frames, or you also check the uplink frames coming from the station side, and DSCP mapping is working perfectly on TID?
So with one vendor camera, we are observing that the vendor A camera is not actually following the QoS. It's just sending the normal data frames. It's not following the QoS. While with the other vendor camera, it's following the QoS and it's tagging the bits properly. It's following actually the best effort.
So means we can see the uplink frames from the station side also?
Yes, true.
Okay.
Thank you so much, Deepika, everyone.
Thank you.